Okay guys, so now we are going to look at how strength of nucleophile will lead to which nucleophilic substitution reaction. So you can have strong nucleophile or weak nucleophile. Okay, so if you have a strong nucleophile, using a strong nucleophile will promote Sn2 mechanism. Okay, maksudnya awak akan nucleophilic attack tu daripada belakang. Okay. So if you have a weak nucleophile, you will promote Sn1 mechanism. Okay. Alright. So let's look at the examples of strong nucleophiles. So let's say for hydrolysis reaction, okay, an example of strong nucleophile is NaOH. Okay, so let's just look here. Okay, NaOH. So how is NaOH a strong nucleophile? Awak just kena ingat yang bila awak punya anion tu dia attached to a metal, okay, like sodium, potassium, okay, selalunya these two, dan awak punya hydroxide ion is very generally very ionic lah, very negatively charged. So dia a strong nucleophile, okay, akan promote Sn2 mechanism. So let's say for alcoholysis, an example is when you have an alkyl group and then you have an O- here. So contohnya macam CH3, CH2 tu our group awak O-, and A+. Dia ni macam salt lah, okay. Others is this carboxylate ion, okay, COO- ni, or Cn-, cyanide ion, okay. It exists as NaCN atau KCN, okay. Itu adalah strong nucleophile, or NH2-. So dia akan attach to maybe Na+ ke apa-apa lah, okay. So asalkan awak guna strong nucleophile, then your mechanism will be Sn2 type of reaction. So let's look siapa yang favor Sn2. Okay, so Sn2 mechanism, awak tahu yang dia adalah nucleophilic attack dia daripada belakang, back attack. It depends on the steric factor. Steric factor, okay. Steric factor is contohnya how much space is used by your substituent. If you have an alkyl group, okay, macam CH3, okay, this CH3, it actually takes a lot of space. So maksudnya awak punya molecule kalau ada banyak R group, dia akan jadi sterically hindered. Jadi dia tak boleh undergo Sn2, okay, sebab awak akan ada back attack, okay. So maksudnya Sn2 ni, it is made for molecules that do not have steric hindrance lah, okay. Tak ada block by R groups tu, okay. So siapa yang paling sesuai untuk undergo Sn2? Methyl halides, okay. Kalau tengok belakang ni, okay, dekat back ada hydrogen saja. Hydrogen kecil, so nucleophilic attack tak ada masalah untuk attack daripada belakang. So methyl halide Sn2. Primary haloalkane pun awak ada satu je R group, so tak ada masalah. It is not sterically hindered. Therefore you can attack from the back, okay, by Sn2 mechanism. Secondary haloalkane pula pun ada possibility untuk undergo Sn2, okay. Okay, unless you have a very bulky substituent yang lebih besar, then ada probability lah yang awak bukan undergo Sn2 tapi Sn1. Tapi ini awak kena tengok pula dia punya nucleophile, okay. Kalau guna weak nucleophile, okay, dengan secondary, maksudnya itu awak Sn1 lah, okay. Kalau dia secondary, lepas tu dia boleh buat rearrangement jadi tertiary, okay, maksudnya dia memang Sn1, okay. Kalau dia secondary, lepas tu dia guna weak nucleophile, maksudnya Sn1, okay. Kalau dia secondary dia guna strong nucleophile, maksudnya awak boleh buat rearrangement lah, 1,2 hydride shift atau 1,2 methyl shift. Okay. Kalau tengok tertiary haloalkane, you have 3 alkyl groups. So this 3 alkyl groups, these alkyl groups are very big. Okay, it takes up a lot of space. So awak punya molecule is sterically hindered. Dia ada block ni, dia block. So that means that awak punya nucleophile, okay, dia tak boleh nak lalu sini sebab dia macam banyak block, okay, banyak molekul kat sini. Steric effect dia kuat sangat kat sini. Okay, so that's why tertiary haloalkane will most definitely never undergo Sn2. Okay, not made for tertiary haloalkane. So this is how steric factor, okay, main peranan untuk allow Sn2 atau tak. Okay, so sterically hindered molecules like tertiary haloalkane will not undergo Sn2. So they will undergo Sn1. Okay, dia tak boleh ada back attack. Okay, tak boleh. Yang lain ni boleh sebab dia sterically low steric effect. Okay, dia tak hindered sangat, dia ada space untuk attack. Alright. Okay. Right, so let's look at Sn1. Okay, kalau awak guna weak nucleophile, you will promote Sn1 mechanism. Okay, contoh weak nucleophile, okay, adalah, let's say for hydrolysis, it is water. Okay, dia tak ada metal pun. Okay, so dia tak berapa negatively charged lah, tak kuat sangat. Okay, dia tak ionic macam yang ni. Okay, for alcoholysis, let's say contohnya ethanol. Okay, whatever ROH. Okay, apa-apalah panjang macam mana pun, selalunya ethanol, methanol. Okay, dia bukan attached to metal, dia alkyl group, so dia dikira weak nucleophile. Okay, NH3 pun, NH3, okay, dia attach to hydrogen je, kan? So ni kat sini awak punya lone pair tu. So ini kira weak nucleophile juga. So kalau awak ada nampak guna nucleophile macam ni, maksudnya awak akan ada Sn1 lah, Sn1 mechanism. Okay, alright. So for Sn1 mechanism, dia akan attack daripada front, kan? So tak ada masalah pasal steric factor tu. So kita akan tengok apa? Kita akan tengok stability of carbocation. So siapa carbocation paling stable? Tertiary kan? Tertiary carbocation kan? So since Sn1 dia ada 2 step, which is you are going to first form your intermediate carbocation, step 1 tu, ini akan leave. So kalau awak ada, okay, ni 3 kan, ni macam ni, so maksudnya macam ni, ting. Okay, ni carbocation awak, tertiary carbocation, right? So dia paling stable, kan? So bila awak ada front attack ni, okay, tak. So Sn1 ni, asalkan awak form a stable carbocation, dan most likely lah awak punya haloalkane tu akan undergo Sn1. Okay, sebab tu tertiary dengan secondary haloalkane paling sesuai untuk undergo Sn1, sebab kita tengok stability of carbocation. Okay, kalau primary haloalkane ni, dia not likely, tapi if your haloalkane can undergo rearrangement, okay, kalau dia boleh undergo rearrangement to form a more stable carbocation macam secondary atau tertiary carbocation, then it can undergo Sn1. Okay, so macam mana nak senang, kita tengok kita punya chart. Let's say kita ada primary atau secondary haloalkane. First, we're going to see whether it has a bulky group or not. Does it has a bulky group? So kalau dia ada CH3 Dia ada CH2, CH3 kan. Besar lah tu kan. So maksudnya dia bulky lah. So kalau dia ada bulky, dia ada steric factor ni. So steric hindrance. So dia tak sesuai untuk undergo Sn2. Tak boleh. So dia akan undergo rearrangement untuk form a more stable carbocation. Okay. And perform Sn1. So let's say if your primary or secondary haloalkane, it is not bulky. So no steric hindrance, no steric factor. So tak ada masalah untuk dia ada back attack. So dia akan undergo Sn2. Okay. So primary haloalkane ni kalau dia boleh rearrange into a more stable carbocation, then dia boleh undergo Sn1. Kalau tak boleh Tak boleh. Kalau tak dia Sn2 je. Okay. So tertiary haloalkane. Bila tertiary haloalkane je, kita most definitely dia akan undergo Sn1. Okay. Sebab dia akan form stable tertiary carbocation. Alright. Okay. So itu kita dah tengok pasal strong nucleophile dengan weak nucleophile kan. So contoh kita boleh tengoklah reactions kita sekarang ni, substitution reactions. So if here this is an hydrolysis of haloalkane with aqueous solution of NaOH. So NaOH in water atau tulis as NaOH aqueous. Okay. Ini adalah hydrolysis. Okay. So kita akan form alcohol. So macam mana kita punya nucleophile will be OH minus yang akan menggantikan awak punya halogen X2. So we will form ROH. So dari sini you know that here NaOH is a strong nucleophile. That means that for this reaction, okay, you will undergo Sn2 mechanism. Okay. So that means awak punya haloalkane tu akan jadi apa? Akan probably primary atau secondary haloalkane. Okay. Tertiary memang tak. Okay. Right. So macam ni, if you have haloalkane reacting with KCN, potassium cyanide, we know that Cn- is a strong nucleophile. That means that this is a Sn2 mechanism. Okay. So Sn2 mechanism macam tadi, awak akan ada primary atau secondary haloalkane. So dalam contoh ini ni, awak ada primary haloalkane. Okay. Awak attach to one R group. Okay. Okay. This reaction is useful when you want to add the number of carbons in your product. Okay. So reaction ni useful lah. Bila awak react dengan KCN, awak boleh tambah one more carbon. Okay. Note that. Okay. Ini reaction with ammonia. So ammonia, we know that NH3 is a weak nucleophile. Okay. So kalau weak nucleophile, that means that dia akan promote Sn1. Okay. So kalau dia promote Sn1, that means that awak punya class of haloalkane will be tertiary atau secondary. So kalau primary tu yang dia boleh rearrange lah, tapi awak akan definitely form secondary carbocation atau tertiary carbocation. So if you look here, ini awak punya reactor ni, dia adalah secondary haloalkane. Okay. So in this reaction, awak akan form amine. Ini saya highlight ni supaya awak boleh nampak which molecule will be attached to your R group and which will be attached to your X. Okay. So awak dapat amine dengan awak punya byproduct. Alright. So ini hydrolysis with water. So this is a weak nucleophile. Maksudnya dia adalah Sn1. Okay. So in Sn1, tengok ni awak ada tertiary haloalkane. Okay, dia macam tu je. So yang lain ni awak boleh tengok lah. Ini alcoholysis reacting with ROH. So maksudnya contoh ni awak punya R group CH3 CH2. Okay, alcohol react dengan haloalkane. Haloalkane awak berapa dia punya kelas? 1, 2. Secondary haloalkane. So kita akan dapat ether. Ether tu COC. Okay. So yang ni, okay, sambung dengan yang ni. Okay. Boleh? Dia macam ni. Dia ada delta negatif, kat sini delta positif. So yang tu, yang opposites akan attract lah. Kita yang kat sini. Ni delta negatif, so ni delta positif. So your opposites will dia akan bersambung lah. Okay. Macam mana ni tau. Tapi awak tak payah belajar lah yang tu dia punya penyambungan tu. Nanti kita tengok kat mechanism. Alright. So yang lainnya awak tengoklah sendiri, okay? Alright. Okay, ni one more thing. Type of reaction, elimination reaction. The name of the reaction, the name of the reaction is dehydrohalogenation. So kalau dehydrohalogenation of haloalkanes, you will get alkene. So ingat balik, ni preparation of alkene. So awak dah belajar dah sebelum ni. Okay. So basically nak so let's see. Oh my god, what are you doing? Sana nak. Astaghfirullahaladzim. Sorry guys. So basically if you have 2 hydrogens with different class, okay, kalau buang this hydrogen with this Br, awak akan dapat double bond kat sini. If you buang this hydrogen with this Br, you will get double bond kat sini. This will be your minor product and this will be your major product, okay? So ingat balik lah Cesar rule tu. Alright. Okay. Right.